All right. We were discussing the EFA process. So let us discuss an example. EFA, how to conduct the EFA. So I have shared with both of my participants some data in my Friday session. I have shared a data example final data set. So I will open it, and this is related with this questionnaire. It is the questionnaire of one of my project where I have developed this questionnaire from the literature, and then I applied the scale validation process using the EFA. So whenever you develop a questionnaire where there is no questionnaire previously available in the literature, or you are not adopting any questionnaire from the past study, rather you are basically developing a new questionnaire with new items, then you need to consider EFA process for validating your questionnaire item. So uh, this was the questionnaire that I developed for one of my study. Let me discuss with you. This questionnaire survey is intended to analyze my research project, the effect of staff training duration, and project scheduling on the project success of Qatari service sector. So you can see here the training duration and project scheduling. Both were independent variable, while the project success, that was the dependent variable. So I basically developed the items using these variables. These are the demographic profile for the respondent. Then these are the basically items relevant to employee training duration. So I have developed a lot of items here relevant to long-term training duration, short-term training duration. For example, you can see here short-term training duration and project success. Then you can see here the long-term duration training and project success. So I have developed a number of statements and on a 5-point Likert scale. So I need to validate whether these items are, according to the software, are valid items or not. So this is the data that I have collected, and you can see here these data comes from how many respondents. This data comes from 456 respondents. So I have discussed with you the sample size requirement here. You can see here there are some guidelines regarding the sample size. If the sample size is less than 300, check the average commonality of the retained item. An average value of 0.6 is acceptable for sample size less than 100. An average value between 0.5 and 0.6 is acceptable for sample size between 100 to 200. So this 0.5 sample size is basically used when you have a data for more than 300 observations. So in my case, I have a data of, you can say, more than 300. It is 456 observation here. So I need to follow 0.5 guidelines. So what is the procedure? How we run the EFA, how we validate the scaled item for our questionnaire whenever we need to develop a questionnaire. So we go to analyze, we go to dimension reduction, we go to factors. So after that, what we need to do, we need to put the factors in the variable box, and then we need to consider the descriptive option here, and then we need to choose all these options here, like initial solution, coefficient, significance level, determinants, and KMA, and Bartlett test of sphericity. So from the right, inverse, reproduce, and anti-image, these are the options that we are not going to choose, and univariate descriptive we are not going to choose. Then after that, we need to consider the principal component analysis, and from there, we need to consider unrotated factor solution and scree plot. And as a basic option, we need to consider the eigenvalue equal to 5. So this is the by default criteria that we should not change here. Then as a next part, we need to consider which rotation method we need to choose. As I have discussed with you that if your factors are not correlated, then you need to consider the varimax rotation. By default, you should choose it. But if your factors are highly correlated, then you need to consider the direct Obliman, this method. Then, as a next procedure, you need to consider the save as variable as a regression, display factor as a score coefficient matrix, and so on. So these are the other options that we need to consider, and it will automatically remove the items having less than this score. This is the basic criteria that you need to follow. So you will see some commonalities, but let me show you this procedure with our data. So this is our data. For example, I need to consider some of the factors, like for example, the largest pool of factor is PS1 to PS16. This is the largest pool of the factors. So I need to consider analyze, then dimension reduction, analyze dimension reduction factors. So I need to put all those factors that I need to consider for EFA. For example, these are the factors which are related with a single variable. So what I need to do, I go to descriptive. From here, I need to consider initial solution, coefficient, significance level, determinant, KMO and Bartlett test of sphericity, and continue. Then from extraction, I need to consider unrotated factor solution and scree plot. And the remaining I will consider as they are by default. Click on continue. Principal component method should be selected as a by default method. Click continue and then go to rotation. As I have discussed with you that we are supposing here, we suppose here that our factors are not correlated. It means these factors, these 16 factors are not correlated with each other. So we will consider the very max rotation. So rotated solution and maximum iteration for conversion 25 by default. Click continue, then go to score. Save as a variable, regression, display factor, score as a coefficient. Then option from here, if we would see here, we need to consider exclude cases list-wise, sorted by size, suppress small coefficient. So from here, sorted by size, suppress small coefficient, and absolute value. It means we need to consider a value with at least 0.30 as a guideline that was provided for EFA. So after doing this, you need to click on OK. So it will run the EFA. So first of all, you are going to see the correlation matrix. You can see here the correlation between the factor, but this is not important here. The first thing that you need to consider here is the KMO and Bartlett test. The value of KMO and Bartlett test should be at least 0.50, and it is greater than 0.50. It is approximately 0.92. So this is a very good KMO value. and it should also be significant. So our value is greater than 0.50 and it is also significant. This is similar the guideline that I have provided you with this process. This is the value. If you see here, the B option, I have mentioned here, check the adequacy of the sample size using KMO statistic. A minimum acceptable score for this test is 0.5. So if we see here, our KMO value is greater than this minimum criteria. So minimum value should be 0.50, but here our value is greater than 0.50. So this is a very ideal value here and it should be significant. The next thing that we need to see is the commonalities value. Here you can see the commonalities value. I have provided criteria here for commonalities value. Let me show you the criteria. Yes. If you see in step number 3, remove any item with commonalities less than 0.20 and then rerun the procedure. So here you can see that the commonality score is greater than 0.20 for every factor. Here is no value with 0.20. So if you find any factor with 0.20 value, you need to rerun the procedure without considering that factor. It means, let's suppose if we found that PS9 having a commonality value, let's suppose 0.19, which is less than 0.20, then we need to rerun the procedure without considering PS9 in the next EFA procedure. We need to run the EFA procedure without PS9 again. So that is the solution. The next thing is the total variance explained. There are the guideline here that you need to follow. For example, uh, there is a guideline. There is a guideline of variance that I have discussed. I think that is also 0.50 guideline. So you need to see here in total variance explained. Yes, total variance explained will let you know how many factors or how many components you can create with these factors. So here, if you can see, they are supporting only one component. It means that from PS1 to PS16, there are only one component. There should be no more than one component here. So the percentage of variance you can find here is given for your consideration. I was discussing that you need to see how many components we can create. So it is supporting that you need to consider only one component. The minimum variance percentage of variance should be 0.50. So a minimum variance should be 50%. So there is more than 50%. And you can see here the scree plot. It is supporting also that there should be one component here because it is basically dropping from the one component only. So these are the component metrics that you need to consider here. There are some guidelines regarding these component metrics. For example, uh, let me show you. Yes. If you see step number 5, step number 5 says that remove any item with factor loading less than 0.30. So if you see these values, these are known as factor loading values. So it is supporting that there should be only one component here. So these values should be greater than 0.30. So these values are greater than 0.30. None of the factors are less than none of the factors are less than 0.30. So if you find any factor with a value less than 0.30, then you need to remove that factor. So this is all about the EFA procedure. You can also design the EFA procedure if you want to run. For example, if I need to consider that there should be three component on these factors, I can run this procedure again. For example, I go to dimension reduction, go to factors, descriptives. Descriptive should be same, then extraction. Here, from the extraction part, you need to change the eigenvalue criteria. If you set on one, it will consider minimum one component. If I set it, for example, I set it for three, it will generate three basically the factors or components here. So you will see here, the only thing that will change, it is not considering three different factors. It is still supporting the single factor component here. Extraction three. Yes, you need to check on fixed number of factors. Let me check this with three. Continue and okay. Now you will see three factors, three different factors or three components here. Yes, you can see here there are three components. So here are the three components, and you can also find here the three different components with their values. So this is how you can consider the EFA. I hope you will understand the procedure. You just need to practice it, how to run an EFA and how to interpret the values. As I have mentioned the criteria here, you need to